In this video, we're going to be looking at areas of compound regions. So we're still looking at the area between two curves, but this time the regions are a little bit more complex. Taking a look at this first example right here, we have two curves. We have the curve of the square root of x, and then we have the other curve, which is 3/2 minus 1/2 x. And so we want to find the area bounded by those two curves and evidently the x-axis right here. So that would be all of this area in here. So we go to our normal formula, and the formula is we find the integral from a to b of the top function minus the bottom function, dx. Well, the problem here is that the top function changes. The top function changes at 1. The top function from 0 to 1, we have from 0 to 1, we have the square root of x, and that would just be, and then y equals 0 there, dx. And then from 1 to, I believe it would be 3, the integral from 1 to 3, we have the other function 3/2 minus x over 2 is the top function. So the moral of the story here is we have to set up two integration problems. The second example is a little bit more complex in that the graphs actually cross. If you could blow this up a little bit, you can see that they cross here, they cross here, and they cross here. So if we want to find the area bounded by these graphs, we have this area in here between the curves, but we also have this area in here between the two curves. So once again, we have to set up two integrals because the curve on top is actually going to change. So let me just get rid of some of that so we can see it. And so from this point here, I'm not sure what that point is. We could actually graph this problem in Desmos. From there to here, then the function f of x, which I believe is x cubed. It's a little bit hard to read here. So we have to set up the integral from a to b, whatever a and b are, of x cubed, that's the function on top, minus the function on the bottom, which is x squared plus x dx. And then we have to set up a function, so let's call this a, let's call this b, and let's call that point c. Now we have to set up the function from b to c, and now x squared plus x is on the top, minus the function x cubed is on the bottom. And so we want to add these two areas together. And so that is the basic idea with what we're going to be doing here. And so here's the formal definition of finding the area of a region between the two curves. Don't get concerned with the fact that this uses the absolute value symbol here. See if you can figure out why they're doing that. But the way that I explained it is actually the way that you carry out using this particular rule with the absolute value symbol. So let's go through and do our first example. My notes are a little bit out of order here, so let's skip ahead. Exercise 4. So trigonometric function. If r, I put a in here, but yeah, this area r. If r is the region between the graphs of f of x equals sine of x and g of x equals cosine of x over the interval from 0 to pi, find the area of the region r. Okay, so that's r, and that's also part of r. So r changes. We have this area over here where the cosine function is on top of the sine function. And then we have make that in green. This part of R where the sine function is on top. And so we need to know where these functions are crossing. Well, we want to go from 0 to pi. So this is pi right here. There's pi. And so they cross over here at pi over 4. So our first interval is from 0 to pi over 4. Our second interval is going to be from pi over 4 to pi. And so I set up two integration problems. Again, from 0 to pi over 4, cosine of x minus sine of x, because cosine is on top, sine is on the bottom. And then my second integral is from pi over 4 to pi, where sine is on the top and cosine is on the bottom. And then, of course, we want to add these two together. So here is the complete set up integration problem. When I say what is the integration problem, that would be the integration problem. It would be the sum of those two integrations problems. All right, so from here, it's just a matter of integrating. Now, I skip a lot of steps from here on in because you should be able to go through and do these problems without too much fuss. So the antiderivative of cosine is sine. The antiderivative of negative sine is positive cosine. The antiderivative of sine, again, is going to be negative cosine. Antiderivative of negative cosine is negative sine. And we're evaluating these from pi over 4 to 0, and those from pi to pi over 4. You end up with 2 radical 2, which is 2.82. Now, you can go through and use Desmos once again to check these. So just like I showed you in the very first video, set up this entire integration problem in Desmos and see what you get. And it will give you a decimal answer of 2.82. I'm not going to go through and do that again in this video. If you have any questions about how to do this in Desmos, let me know, and I can do another video on just setting up an integral in Desmos. And one more problem. Exercise 5. Find the region enclosed by y equals 2 divided by x, y equals 8x, and y equals x over 8. So graph the three functions in Desmos. Get a good look at what you're doing. Then make your little sketch here and label everything appropriately. And so the area that we're looking for, again, we have two different integrals to set up. We've got this area in here. Whoops. We've got the area in here that goes from 0 to 1/2. And again, you can find that point right there in Desmos or algebraically, either one. And then we've got our second area, which goes from 1/2 up to 4. So in the first one, from 0 to 1/2, the function 8 over x is on top, and the function 1/8 x is on the bottom. So I set that up here. We have the bounds of integration from 0 to 1/2. 8x is on top, 1/8 x is on the bottom. Then the second integral is from 1/2 to 4, so there's my bounds of integration. The function that's on the top is 2 over x. The function on the bottom, once again, is 1/8 x. Set up the second integral. Put it all together in one nice big integration problem. You can check that in Desmos and see what you get as a decimal number. And then you have to go through and evaluate it algebraically because WebAssign is going to want this answer. Desmos will give you this answer. So you can always take 2 log of 8, evaluate that in Desmos, and you should get 4.15. And you know that you have done it correctly. So you do have some logarithms in here, so you have to remember a little bit about using logarithms. But again, you can even use Desmos to evaluate these logarithms. Let Desmos do all of the basic computational and calculator work for you. All right, so that is finding the area between two curves when you have some type of a compound area. That's it for this video. See you next time.